Breaking news from Starbase, Texas. SpaceX has just achieved a remarkable milestone in their Starship program, a massive static fire test of all 33 Raptor engines on Booster 14. This crucial test, lasting an unprecedented 10 seconds, marks one of the final steps before the highly anticipated Flight 7 launch. The test lit up the Texas sky as Booster 14, equipped with the latest generation of Raptor 2 engines, roared to life. This isn't just any ordinary rocket test. It's a demonstration of the most powerful launch vehicle ever built, showcasing SpaceX's relentless push toward their next orbital flight attempt. With Elon Musk confirming preparations for Flight 7 and the FCC granting a launch window starting December 17th, we're witnessing history in the making. This incredible new booster features refined structural reinforcements and upgraded plumbing systems, representing the next evolution in SpaceX's revolutionary Starship program. Welcome to Elon Musk 24 Hours, your premier source for the latest SpaceX developments and breakthrough achievements in space technology. Let's dive right in. The sun hadn't yet risen over Starbase when SpaceX engineers gathered for what would become a historic morning at the Texas facility. As the first rays of light painted the sky, Booster 14 stood majestically on the launch pad, housing 33 of the most advanced rocket engines ever created. The tension in the control room was palpable. Years of innovation, countless sleepless nights, and the dreams of making humanity multi-planetary all culminated in this moment. The static fire test of Booster 14 wasn't just another checkbox on the path to launch. It represented a technological leap that even SpaceX's most experienced engineers found breathtaking. Each Raptor 2 engine incorporated innovations born from failures, breakthroughs, and relentless iteration. The plumbing system, a maze of pipes carrying supercooled propellants, had been completely redesigned based on data from previous flights. Engineers had spent months perfecting the structural reinforcements, using advanced materials and techniques that pushed the boundaries of aerospace engineering. As the countdown began, the morning silence was shattered by the deafening roar of all 33 Raptor engines igniting simultaneously. For 10 seconds, an eternity in rocket engine testing, Booster 14 demonstrated its raw power. The ground trembled, and the Texas sky illuminated with a brilliant flame that could be seen for miles. When the engines finally shut down, cheers erupted in the control room. But this was just the beginning of an even more ambitious journey. The story of Flight 7 actually began months earlier, in the aftermath of Flight 6's unexpected conclusion. During that mission, a critical communication failure between the booster and the launch tower's catching mechanism led to a split-second decision that would reshape SpaceX's approach to landing procedures. The team had to choose between attempting a risky catch or executing a controlled ocean splashdown. In that moment, years of SpaceX's safety-first culture paid off. They chose the conservative approach, gaining valuable data while protecting their revolutionary hardware. Behind the scenes, this decision sparked an intensive engineering review. Teams worked around the clock, analyzing every byte of data from the communication system failure. They discovered that the issue wasn't just technical. It revealed the need for a fundamental redesign of how the booster and tower systems interact. This led to the development of a new, redundant communication architecture that would prove crucial for Flight 7's ambitious goals. Ship 33, the upper stage destined to pair with Booster 14, represents another quantum leap in spacecraft design. Unlike its predecessors, this Block 2 variant incorporates lessons learned from every previous Starship flight. The thermal protection system has been refined through countless tests in plasma wind tunnels. The header tanks, crucial for landing operations, have been redesigned to provide more reliable propellant flow during the complex flip maneuver. Each modification tells a story of engineering persistence and innovation, but the path to launch isn't just about technical achievements. SpaceX faces challenges that extend far beyond the physics of rocketry. The situation at Vandenberg Space Force Base has become a testament to the complex interplay between space exploration and terrestrial politics. The California Coastal Commission's decision to restrict launch operations wasn't made in a vacuum. It reflects deeper tensions between environmental concerns, political ideologies, and the future of space exploration. Vandenberg's strategic importance cannot be overstated. Its geographical location makes it irreplaceable for certain mission profiles, particularly polar orbits essential for Earth observation and military satellites. Unlike other launch sites, Vandenberg offers a unique southward trajectory over the Pacific Ocean, avoiding populated areas and providing optimal conditions for specific orbital insertions. The facility's infrastructure, built up over decades of space operations, represents billions in investment and years of operational experience. The Commission's decision sent shockwaves through the aerospace industry. SpaceX's response was swift and multifaceted. While their legal team prepared a federal lawsuit challenging the Commission's authority, engineering teams began an intensive study of alternative launch sites. Florida's Space Coast emerged as a potential solution, but launching polar missions from there would require complex dogleg maneuvers, increasing fuel requirements and reducing payload capacity. Despite these challenges, SpaceX's preparation for Flight 7 continues unabated. The mission profile pushes the boundaries of what's possible with current technology. After stage separation, Booster 14 will attempt something never before achieved: a return to the launch site under its own power. This precision maneuver requires perfect coordination between the booster's guidance systems and the ground infrastructure, with margins of error measured in seconds and meters. The launch tower itself has undergone significant modifications. The catching mechanism, nicknamed Chopsticks by SpaceX employees, now features enhanced sensors and more robust actuators. The team has implemented a new suite of weather monitoring instruments, providing real-time data about wind conditions at different altitudes. These improvements reflect lessons learned from previous attempts and demonstrate SpaceX's commitment to achieving reliable, repeatable booster recovery. As Flight 7 approaches, the engineering teams face an intense period of integration testing. Ship 33 will undergo its own static fire test, verifying the performance of its Raptor engines in the space environment. The mating procedure between Ship 33 and Booster 14 must be executed with millimeter precision, ensuring perfect alignment of mechanical and electrical connections. Each step is choreographed and rehearsed, leaving nothing to chance. The timeline for launch depends heavily on the Federal Aviation Administration's review process. While the standard review period is 80 days, SpaceX has worked closely with regulators to streamline the process without compromising safety. The company has implemented new safety analysis tools, developing sophisticated models to predict debris trajectories and potential impact zones. These efforts demonstrate SpaceX's commitment to responsible spaceflight operations. Looking ahead, Flight 7 represents more than just another test flight. It embodies humanity's relentless drive to explore space and SpaceX's revolutionary approach to spacecraft development. The integration of Ship 33 with Booster 14 brings together the most advanced rocket technology ever created, setting the stage for a new era in space exploration. As teams at Starbase make final preparations, the excitement builds not just within SpaceX, but throughout the entire space community. The success of this mission could reshape our understanding of what's possible in rocket reusability. A successful booster return to launch site would validate years of research and development, potentially reducing launch costs dramatically. The enhanced communication systems and refined landing procedures could become the standard for future spacecraft operations, influencing the entire industry's approach to reusable rockets. As Flight 7 approaches, we stand at the threshold of a new chapter in space exploration. The successful static fire test of Booster 14 isn't just a technical milestone. It's a testament to human ingenuity and SpaceX's unwavering commitment to making space accessible. With each ignition of those 33 Raptor engines, we move closer to a future where interplanetary travel isn't just a dream, but a reality. The challenges faced at Vandenberg and the innovative solutions being developed demonstrate that the path to the stars isn't always straight. Yet SpaceX continues to adapt, evolve, and push forward, turning obstacles into opportunities for advancement. The upcoming launch represents more than just another test flight. It's a bold step toward revolutionizing how we access space. From the enhanced communication systems to the refined landing procedures, every improvement on Flight 7 builds upon the lessons of the past while reaching toward the future. As we eagerly await the launch window opening this December, one thing becomes clear. We're witnessing history in the making, one launch at a time. Stay connected with Elon Musk 24 hours for exclusive coverage of Flight 7 and all future SpaceX developments. If you found this insider look at SpaceX's latest achievements valuable, please support our channel by hitting the like button and subscribing. Share this video with fellow space enthusiasts who share our passion for innovation and exploration. Join our growing community by activating notifications to never miss an update on SpaceX's groundbreaking missions. This is Elon Musk 24 Hours, where we bring space innovation down to Earth. Until next time, keep looking up. The future is closer than you think. Breaking news from SpaceX. A groundbreaking shift in spacecraft protection is on the horizon. During Starship Flight 6, SpaceX deliberately removed over 2,000 heat shield tiles from S-31, pushing the boundaries of aerospace engineering in a bold test that's changing the future of space travel. The results? Stunning purple-blue discoloration across the spacecraft's surface and visible deformation during re-entry. But here's the twist. These weren't failures. They were calculated risks that revealed crucial data about the next evolution in spacecraft protection. Metallic heat shields. This is more than just a material change. It's a complete reimagining of how we protect spacecraft during the brutal conditions of atmospheric re-entry. With temperatures exceeding 1,500 degrees Celsius, hot enough to melt the strongest steels, SpaceX is pioneering a revolutionary cooling system that could make ceramic tiles obsolete. In today's deep dive, we're going to reveal exactly what happened during Flight 6's daring heat shield test, why Elon Musk believes metallic shields are the future, and how this technology could be the key to landing humans on Mars. Welcome to Elon Musk 24 Hours, your premier source for SpaceX innovations and breakthroughs. Let's dive right in. The story of Flight 6's heat shield test begins 47 seconds after launch, on a morning that would change spacecraft design forever. At Mission Control, engineers held their breath as Starship S-31 climbed through the atmosphere. The massive rocket looked magnificent against the dawn sky, but beneath its gleaming surface, an unprecedented experiment was already underway. At T+49 seconds, the first signs appeared. "We're seeing initial deformation on the hull," called out the flight director, their voice steady despite the tension in the room. What happened next would challenge everything we thought we knew about spacecraft protection. The birth of a bold idea. 3 months before Flight 6, in a late-night engineering meeting at SpaceX headquarters, Elon Musk had proposed something that seemed almost impossible. What if we